Trig functions of any angle. Moving right into 1.4 of our Larson text. This will be our first video now. Because we didn't do 1.2, and I teach this a little different. I'm going to give you a little lead in. We're just going to talk about some angles here, and this is how we're going to get comfortable with where things go. It's going to make your life a hell of a lot easier. We just kind of go step by step breaking this up. I look at your text, and it just wants to introduce something right away. I'm like, you know what? Why don't we build some angles first? Let's just look at some angles. Sure, we got it. Let's start in degrees to get that full understanding. So I just drew something up. Just a little something. And it's your XY graph, right? It's just the XY. But with our new fancy things on it, right? So that should say X, not Y. Sorry about that. But still an XY graph, but we can superimpose our degrees, right? So we know that if we move in our counterclockwise direction, we'll be going in the positive direction. So we go from 0 degrees up to 90, and then 90 more is 180, and 90 plus 180 is 270. We went back around in the circle, what would we get? Heck yeah. Be coterminal. Coterminal there at it's 0 degrees and 360. Those are coterminal angles. They terminate in the same spot, huh? Think about those words. They terminate. They end in the same spot. Cool. But like I said, we want to build angles here. So let's start thinking. Let's go find, I have these little light blue dashed lines here. What do you think this angle is? If it's cut perfectly in half between 0 and 90, what's half of 90? Half of 90? Well, half of 90, we're like, what's that? Well, that's 45 degrees. We're like, okay, well, this angle here is 45 degrees if we're opening up from our positive x-axis. There's a 45 degree angle. Neat. Cool. And then, so 0 degrees, 45. So 45 plus 45 is equal to 90. And then what's 90? What's 90 plus 45? Wow. You know what I mean? 90 plus 45. Oh, that's 135 degrees. And that's why we're going to choose this one. Now 135 plus 45, going 45 more, another 45. What's 45 plus 45? Wow, this just came out of the refrigerator too. I'm surprised it's so messed up. 45 plus 135, that's equal to 180. And we're going to keep playing this game. Just 45 degree angles, because half a 90, right? Half a right angle is 45, right? Half a right angle being 90, you cut it in half. So what's 180 plus 45? Now, I screwed this up in the past one, in one of my lectures, in one of the past ones, talking about coterminal angles. I said it was 215, but 180 plus 45 is actually 225. So thank you to the student that found that. I appreciate you. You're going to get hooked up for calling that to my attention, at least the first person. And then 225 plus 45 is going to get you on over to 270. 270 plus 45 is going to be equal to 315. And then 315 plus 360, or 315 plus 45 is equal to 360. So this angle's a 45. This angle's a 45. This angle's a 45. 45, a 45, a 45, a 45, a 45. Looks like we can break it up. Oops. Looks like we can break this up into 8 pieces. Like 8 times 45. I don't know what that is. Well, whatever. That doesn't mean nothing. Okay, cool. So we got our 45. So that's a common angle. Remember when I asked you to, we need to know like sine, cosine, and tangent of 45 degrees or pi over 4. Yeah, we need to know them. So these angles are highly important. So let's pull out a little ruler here and let's do the other common ones. So let's make ourselves a 30 degree angle. Okay. Let's just go through and kind of get some sort of line going through there. Not too much. And then let's create a 60 degree angle too. Let's see. Oh, I went too far. So you can see it's a 60 degree angle. Oh, there we go. These commons. Cool. So let's just start there. So we're breaking this thing down. You saw at the beginning, we go to, oops, I want to use this. 30 degrees. I just made a little angle from here to here. That's 30 degrees. Just from there's 30. And then what's 2 times 30? Let's go another 30. If we were to go another 30 from here to here, would be another 30 degrees. 30 plus 30 is equal to, that's equal to 60. So 30 degrees, 60 degrees. What's 30 plus 60? 90 degrees. And then we're going to have another one right here. What's 30 plus 90? 120. That's right. So let's draw those in now. See, we're starting to get there. Now, ooh, I'm showing you the trick right now. This is something called a reference angle that I'm drawing. Notice my ruler here says 30 degrees. But we're not drawing in a 30-degree angle, but that's what we call the reference angle. We'll talk more about that. So as I move it up and the angle gets bigger, it's 30 degrees. That's called a reference angle. Yeah, just thought I'd throw that out there. Look, I'm going to make a 60-degree angle. It's a reference angle. It's just the angle down to whatever the x-axis is. But that's for a later time. Don't stress about that. Right now, we're just looking at angles. And we're going to fill this whole thing out. All right, neat. Neat, neat, neat. So we go around that circle. We started, we're like 30, 60, 90, 3, 6, 9. What comes after 12? So 120. 120 plus 30, isn't that 150 degrees? And then what's 150 plus 30? That's 180. What's 180 plus 30? 210. 210 plus 30? 240. 240 plus 30? That's 270. 270 plus 30? That's 300. 300 plus 30? That's 330. 330 plus 30? That's 360 degrees. So look at all of these multiples around in the circle of 30 degrees. Those are all broken down with little chunks in between each of them. 30 degrees, 30 degrees, 30 degrees, 30 degrees, 30 degrees. We're ignoring those 45s. Everything with a 5 on it, say, piss off. We're not looking at you right now. See, those are all little 30 degrees. It's like we can break each quadrant into 3 when we have our 30 degrees. So, neat. Just some numbers. But we need to be comfortable with this because we're about to start throwing shit inside of here. You're going to have to not just know these angles, you're also going to need to be able to recognize where your trig functions are. So let's keep going. Got to do it to y'all. Got to do it. So there's the common degrees. This is what I'm talking about. We need to make another one. So this is going to go around in 0 radians, pi over 2 radians, pi radians. Half plus 1 is 3 over 2. So 3 pi over 2. And then we go back up to 2 pi radians. Now we're going to play that same freaking game, except I'm not going to make it so perfect this time. I'm just going to go, hold on. Look like this. No, I'm not. No, I'm not. That's terrible. That's terrible. All right. We were actually going to do it. I'll make a 45. A 45. A 30. Well, my 30 was way off. I guess I wasn't even close, huh? You draw it all the way through. You got your 60. Are we seeing how these angles are working? It's probably not the worst thing in the world to see this again, unless you're super comfortable with all of your degrees, or maybe you've messed around with this before. Maybe you're repeating this. Maybe you're taking this course after calculus. That happens sometimes. Sometimes students are like, hey, I want to know my trig better. Okay. Now let's go get this. So first let's go around in our 45s. Let's go get our 45s. And that's pi over 4. That's the same thing. So a quarter of a pi plus a quarter of a pi is a half a pi. A half a pi plus a quarter of a pi is equal to 3 pi over 4. You give it another pi over 4 and you're going to end up at pi. 4 pi over 4. Same thing, just making a common denominator out of our quadrantial angles. You add another one. What's 1 more than 4? What's 1 more than 4? Isn't that 5? 5 pi's over 4? Okay, cool. Now let's add another pi over 4 to 5 pi over 4. And that's equal to 6 pi over 4. Right? 1 more pi over 4. That's 6 of them. But if an even number over an even number, half of 6 is 3, half of 4 is 2. Oh shit, that's the same thing. Just like back up here, oh, I just skipped right over it. The 2 pi over 4 must be the same thing as pi over 2. Okay, keep going. We're like, let's add one more to 6 pi over 4. What's one more than 6? 7. So we get to 7 pi over 4. And now that we've come all the way around to the circle, we're like, well, there we go. We get back to 2 pi, which is actually 8 pi over 4. It's the same thing. 8 pi over 4 and 2 pi, that's the same. What's 8 divided by 4? 2. Same thing. So these are all broken up in 45s. Oops, I mean pi over 4 radians. So that's why we broke everything into 45, just like we did back here. We broke all this shit right at the beginning into our 45s. Except we're calling it pi over 4 now. Now we're going to go around in a circle with pi's over 6, because pi over 6 is equal to 30 degrees. Ish. Pi over 3, by the way, is equal to 60 degrees. So we start filling it out. We're like pi over 6, 2 pi over 6. Oh, oops. I'm sorry. I made a mistake. You can't leave an even number over an even number. That must be pi over 3, not 2 pi's over 6s. Let's add one more pi over 6. We get to, we get to 3 pi over 6 right here. 1 pi over 6, 2 pi's over 6, 3 pi's over 6. Next we get to 4 pi's over 6, 4 pi over 6. Notice I write 2 pi over 3, not 4 pi over 6, because that's how you add fractions. Now we go 1 more pi over 6, we get 5 pi over 6. 1 more, we get 6 pi over 6. 1 more pi over 6, we get to 7 pi over 6. And then we go to, about to reduce a fraction. What's 8 over 6? What's 8 over 6? 8 over 6 is 4 over 3. So you get 4 pi over 3. You go to our next, we have 9 pi over 6, which is the same thing as 3 pi over 2. Fractions, just reducing them. I'm just talking about fractions here. You go 1 more, we're going to end up at 5 pi over 3. Oops, I mean 10 pi over 6. And then 11 pi over 6. And then 12 pi over 6. All the way around in a circle. You need to know these radians really well. You got to know these. I know there's fractions, and you're like, I don't like fractions. Tough shit. I mean, that's really how it breaks down. Those are what's in blue, your multiples of 30 there. They're all a gap throughout the whole thing. That this is 30 degrees. I mean pi over 6. This is 30 degrees. Oops, I mean pi over 6. Again. Pi over 6 for all of these. It's just multiples of it. The same way I broke down the 30 degrees, we just broke down pi over 6. They're the same thing. So if you are still not comfortable with fractions, and you're looking at this and you're like, I don't know what's bigger, 4/3 or 5/6 or something like that, you need to get to work. Because this is just repeats over and over. So you can sit and suffer through this stuff repeatedly or get on it. So I know this was a long one. I just want to make sure that we all know where our angles go in both degrees and in radians. So there's our degrees. There's our radians. Okay, we'll be back in the next one. We'll actually start doing some trig.